What's up, everybody? So today we're going to be factoring some polynomials. So I'm going to go through a bunch of different examples and show you some tricks of the trade, and then I'll give you some that you can practice if you want to. But let's take a look at this. So we're going to start with this first one right here and try to factor it. So first thing I look for is factors that are in every single term that I can pull out. So one of those is, in this problem, we can pull out a 20 out of each of these, a factor of 20 out. And then also it looks like we can pull 1x out of everything, because everything has at least 1x. So we can write it kind of like this. And as always, I apologize for my writing, as I am writing with my mouse. Anyway, 20x, we can pull a 20 and an x out of each thing. So this without the 20x is just x squared minus 20 times, I believe, let's see, I'll have to pull out my calculator. 10, 11, is it 11? I believe it's 11. X. And then how many times does 20 go into 600? That'd be 5 times 6, so 30. And there we go. All right, and then we can take this a step further, and we could factor this thing that's inside parentheses. So let's go ahead and do that. So 20x, and then I'm just going to do kind of this little number right here. So we can start out with an x and an x, because x times x is x squared. Since this is a positive, we know they're both going to be the same as this, so we're going to have two negatives. What times what equals 30? Looks like 6 times 5, and 6 plus 5 is 11, so it looks like that's going to work. And I believe that that can't factor down anymore, so that's going to be our answer for number 1. 20x times x minus 6 times x minus 5. Okay, let's take a look at the second one. So first thing I'm seeing is that we can pull an m out of both of these terms. So we're going to have m times m to the 4th minus 81. And what I'm seeing is that this is the difference of squares, and difference of squares is always the square root plus the square root, and then times the square root minus the square root. So let me show you what I mean. So we'll keep the m out front, but then we can expand this to m squared, because m squared times m squared is m to the 4th. M squared plus 9 times 9 is 81, and then m squared minus 9. So this is a very common factorization. When you have the difference of squares, you can always rewrite it as the square root of the first term plus or minus the square root of the second one. So we have m squared plus 9, m squared minus 9 here. And we're not actually done, because check this out. This itself, the m squared minus 9, is itself a difference of squares. So we could actually factor that as well. So let's take this one step further. We'll have m squared plus 9. And then we can factor this. M times m is m squared, so we'll have an m plus 3. 3 times 3 is 9. And an m minus 3. And there you go. This has been completely factored here. All right, let's look at a few more. So number 3. Let's see what we can bring out of this. So this is a sum of cubes because 3 times 3 times 3 is 27. A times A times A is A cubed. 2 times 2 times 2 is 8. And B times B times B is cubed. So watch out for these because every once in a while you'll find these. This is a sum of cubes, and I have a special rule for the sum of cubes, and I want to show y'all that real quick. So this is the sum of cubes and the difference of cubes. So anytime you have a sum of cubes or a difference of cubes, you can use these patterns. So we can see to factor our problem, a cubed plus b cubed, we can factor it kind of like this right here. So a plus b, a squared minus ab plus b squared. So we're going to go ahead and do that. A squared minus ab. Okay. So first of all, we have the a plus b. I think that was it, right? So 3a plus 2b, and then times a squared, which is, let's see, that would be 9a squared minus, was it AB? So that's 3a times 2b, so that's 6ab. And I'm just getting this from the pattern. And then plus b squared, right? So 2b squared is 4b squared. And I think that that's as much as we can factor this one. So watch out for the sum of cubes and the difference of cubes because we have those special patterns that we can use there. Now for number 4, we're going to be using a method called grouping to get the answer to this one. So first of all, let's see what we can do here. So we can pull out a t cubed out of each one of these. So let's go ahead and do that. So t cubed, so we'll have 5t cubed plus 2t squared minus 5t minus 2. Now what I'm seeing here is that we have a 5 plus 2 and then a negative 5 minus 2. So what I'm seeing is that we can kind of rearrange these. We can group them to give us what we want. So what we're going to do is we're actually going to separate these we're just going to look at these two terms and we're going to look at these two terms separately. So if we look at the first two terms, we see that we can bring out a t squared. So we're going to do that. So we're going to do t cubed out front. And then out of these two terms, we're going to bring out a t squared. So this will become 5t. And this will become a 2. Okay. And then over here, we can't really bring out anything except a negative 1. Notice how they're both negative. So we could say minus, I'm just going to put the 1 in even though I don't have to, minus 1 times 5t plus 2. Oops. That's not a t. Okay, 5t plus 2. Let me make sure that y'all can see. Oh, no, looks like I'm cutting that off a little bit. It's my mistake. Move this over so y'all can see a little bit. Okay, 5t plus 2. All right, now notice in here what I did with this grouping method. Notice that we have a 5t plus 2 here and a 5t plus 2 here. So we can write this as a factor of t squared minus 1 times 5t plus 2. And that was my strategy there with grouping, is because I saw that I could pull the same thing out of this as I could out of this. I saw the 5t plus 2 and the 5t plus 2. I just had to kind of rewrite them to where the 5t plus 2 kind of showed up. And now we can rewrite this as 5t plus 2 times this t squared minus 1. And that's allowed. You can do that. That's when it comes to factoring, that's an allowed method. All right. And then we see that we could even take it one step further, because this t squared minus 1 is a difference of squares. So we could do t plus 1, t minus 1. So final answer, I think, is, I'm going to write it in here, t cubed times 5t plus 2 times t plus 1 times t minus 1. That's supposed to be a t. All right, and I think that that is the overall answer. Now, when to use grouping, guys, I would say on your problems that you're going to be faced with, I would say probably anytime you have a group of 4, then there's a good chance that you could solve that by grouping. So anytime you see 4 terms that you're supposed to factor, I would try grouping and see if you can get it that way. All right, let's do I guess, did we cover everything? I think that we can, I can show you something else. So I'm just going to go with those 4 examples. I think that covers pretty much all of the tricks of the trade. So now, before we go into these next examples, I want to show you this theorem. So this is the factor theorem. And essentially what it means is that we can test to see if a factor is actually a factor of a polynomial. And we're going to know that because if we take the letter of the factor, or the number of the factor, and change the sign, if we get 0 when we evaluate that function for that number, if we get 0, then it is a factor. If not, it's not. So let me show you what I mean, and we'll work one example here. So what we're going to do is evaluate this function for -1. So we're going to take this number, we're going to change the sign, and we're going to evaluate this function. And if we get 0, then we know it's a factor. If we don't get 0, it's not a factor. So to evaluate this function, we can just substitute -1 in for x. So we're going to have -1 cubed minus 13 times -1 minus 12. Okay, -1 cubed is just -1. -13 times -1 is a positive 13, and minus 12. Okay, so -1 plus 13 is 12. 12 minus 12 is 0. So the answer is yes. X plus 1 is a factor of x cubed minus 13x minus 12. Okay, so that would be a yes. We could do one more, and then we'll call it a day. So let's take this -2, change the sign, and substitute it in. So we'll have 6 times 2 cubed plus 8 times 2 squared minus 34 times 2 minus 12. Now, I'm going to definitely use my calculator for this a little bit. So 2 cubed is 8. 8 times 6 is 48. So this will be 48. 2 squared is 4. 4 times 8 is 32. 34 times 2 is 68. And minus 12. So let's evaluate that. 48 plus 32 minus 68 minus 12 comes out to be 0. So that again is a yes. That's a yes. X minus 2 is a factor. Now I'll let you do this last one, and let's see if I can find the answer to that one. Actually, it looks like this last one is a factor as well. So apparently they gave us all 3 of these are going to work. So we're just showing that the binomial is a factor of the polynomial, so we can use that theorem to show that. And then they want us to factor it, but we got enough practice with the factoring in the video. So I think that that's all that you need to know. So guys, factoring is one of those tricks that you just get good at by doing. So practice, practice, practice. But that's all for me, guys. Hope you enjoyed the video, and I will see you next time.